a couple other ones as well.
Yeah.
All right, that's great.
Twitch. We're on Twitch as well.
Twitch. Very good. Well, so we'll just go ahead and get it started. Welcome to Soil Nerds and Key to Life. And for those of you, I think everybody here is pretty familiar with Key to Life, but if not, then Tate Dooley is our founder and visionary, and the guy who originally started as a hydroponic grower himself, started developing vortex or cyclonic tea brewers, and that's really how he got his start in the supply business, and then came on to develop these powdered soluble organic nutrients. I've been working with Key to Life for going on 5 years now. Started as a rep, and now managing the sales team. And my name is Mike Ballard. But without further ado, let me introduce Tate Dooley. Tate, take it away.
Awesome. Thanks, Mike. Dang, I didn't realize it's been 5 years already. Holy crap, time flies. Oh my gosh, So I just wanted to see how you guys are joining today. If you guys are all joining through Zoom, or if you guys are joining through YouTube or Facebook or LinkedIn or Twitch or, any of these platforms. So throw it into the comments, throw it into the chat, how you're joining today. And just so you guys know, in the future, we're probably going to be massively sending out a YouTube live link for this show, and probably kind of trying to migrate away from Zoom. So thank you guys for jumping over here. We really appreciate it. And I'm also going to be somebody that's going to be joining me today is Kyle Barogi, who is product specialist at KTL, as well as microbiologist. So yeah, what this is all about, guys, is opening up a platform so that anybody and everybody can bring their questions to the table about their garden, their backyard garden, their commercial grow, whatever it may be, or even sustainability, or a lot of other topics that come on with this as well. Oh, Victor Wisdom, youtube.com. Couldn't get Zoom to work on my phone. Okay, perfect. Yeah. Feel free to join on YouTube or at any of the channels. So, Kyle, tee it up. Let us know. Who are you? What are you doing?
Yeah, guys. So my name is Kyle Barogi. I'm Mike said, our product specialist. Tate said I'm a microbiologist as well. Got a background in sustainable soil sciences. I also have some pretty extensive collegiate-based knowledge in things like chemistry and biochemistry as well. Lots of different botany, agriculture of all different types. I help consult with farmers and growers of all shapes, sizes, and types. Everything from your small hobbyist backyard gardener to your large commercial scale hemp farmer, anything in between. We work with citrus farmers. We work with hops farmers. We work with vineyards. We work with leafy green farmers. We work with indoor hydroponic growers. We work with pretty much anybody of any kind. So like Tate said, the point of this session that we're giving and bringing live to you today is we really like participation. We want people to ask questions. We want people to give us real life examples of things that they're dealing with, problems that they've had, struggles that they've got going on. We invite you that if you have any soil reports or anything like that that you want to share with us that you'd like us to go over live, so we can kind of give you a general idea of what good soil looks like, what bad soil looks like, some of the types of recommendations that we may make there in between, whether it be through a regimen of water-soluble powdered fertilizers that we can send to your drip system, irrigation system, long-distance drip line, or whatnot, or a combination of amendments as with the solubles, or just strictly sticking to amendments depending on what your situation is and what you happen to be dealing with specifically. So again, we very much encourage you to, again, anybody on any of the platforms here, whether it be Facebook Live, YouTube, LinkedIn, Twitch, any one of those, if you want to throw us a comment and ask us a question about something you've got going on in particular, we really encourage you to do that. Again, that's really the basis of what we're trying to achieve here, is we're trying to get a community of people move together here so that we can, help solve people's problems, help do whatever they're doing a little bit better. Again, whether it just be problem solving some small issue in your backyard, or answering big questions about, growing techniques, farming practices, sustainable soil agriculture questions, comparisons to other products that are being utilized in the industry, all those types of things as well.
Heck yeah. Yeah, that's what it's about. So I wanted to open it up, and anybody who's on the live stream on the Zoom, feel free to introduce yourself, why you're here, why sustainability is important to you, why you're in this awesome growing industry. Kara, take it away.
I mean, for plenty of years, I've been infatuated with the cannabis plant in general. I found my way into the industry by being a biological consultant. So if you have any question about bugs, I am your bug lady and the lady to ask. I can help guide you in the right direction to get you some of the suitable bugs for your environment, whether it's indoor, outdoor, climate, humidity, all the above, and just continuing to grow into the industry, and being a part of it's really awesome. So I continue to thrive with it, and along with the rest of you guys. So super excited for the future, and keep crushing it.
That's awesome. Yep, we're excited to have the bug knowledge specialist on the team. So feel free to bring any of those questions as well. Who else wants to go? Who else wants to share why they're here?
Looks like Deborah is raising her hand. Hi, Deborah.
Hello.
Yes, that is. She's. Looks like she has some audio troubles, but yes, that is actually my aunt. My aunt Deborah. Thank you for joining us today, Debbie. Appreciate you coming on.
Excellent. Keep it in the family.
My name's Ian. I've been part of the Key to Life team since really kind of like day one, just supporting the movement, the organic agriculture. I did business sustainability. I'm just kind of the guy that talks a lot and tries to bring as many friends together, networker, if you will.
Heck yeah.
I like growing and stuff, and I'm learning a lot from all you. So
That's right. Yep. We welcome Ian. So you guys will see Ian, as many have seen Ian before. You guys will see Ian here now and in the future. So it's exciting. Cassidy, let's hear from the local rock star.
Yeah. Hey, everybody. My name is Cassidy. I do a lot of stuff here at Key to Life, order processing, customer service, pretty much from point A to point B. My hands are on it. I kind of am in all sectors of what we're doing, and I found myself really lucky to be a part of the Key to Life team here. I'm very grateful. We're a great team of people. We offer really great products. I'm continually just learning. I'm learning so much being here, working with all of you. And I really like to garden in my backyard as well. So it's just a perfect pair. And, I also really believe in, the sustainability factor, environmentally friendly products, because I have a daughter and I would like, our backyard to be not, full of chemicals and things like that, like most people. So, yes.
Heck yeah. Feed the family. That's what it's all about. And speaking of feeding the family, we're going to have a barbecue this weekend. So I'm going to remind me after this to invite all the local peeps. So David Hubbard, let's hear from you. Why are you here? What drew you to love organic gardening?
Well, I'm a retired lawyer and a humanities major, so I'm here to learn. I don't know very much about biology or plant care, and I got interested in this because I had an avocation of being a ski instructor. And a few years back, I was having just way too much fun with a bunch of my fellow instructors, and I broke 18 bones. That has gifted me with what I call pretty creaky joints. And I've discovered that the best palliative care without noxious side effects is CBD. And so I've been, and I can't buy a proper concentration. For me, I don't get an effective relief unless I'm dosing with 50 milligrams or more of CBD.
Totally.
And I don't like to smoke, so I make gummies. And I'm feeling my way forward in how to grow the plant and harvest it at, optimum harvest time. And my soil issues have been that I have a very heavy, dense clay soil. I'm up at 1,800 feet in the Berkshires in Massachusetts. So we get a lot of weather. And I've been trying to figure out the best way to manage this, especially with genetics. Most of the stuff I get, is California or Spanish or some other sort of semi-tropical climate genetics, and life's different up here. So I'm trying to learn about everything. I'm here to open my ears.
That's awesome. It's the best way to come to a platform like this, as well as it's the best way to live life, right? We got to always stay learning. That's for sure. Well, yeah, we're all about it. We really appreciate you guys sharing, a little bit of your background. Feel free to continue to chime in as we continue this convo. That's what it's all about. It's all community. It's all interactive. And it's all about learning. So continue to bring any questions or thoughts to the table. With that being said, we're going to go ahead and we're going to get into the living soil versus dead dirt. This has been one of my biggest passions for a really long time. It's actually the main reason that I started Key to Life out of my garage, in 2012 or before. We started as a company called Triple Helix Brewing Systems, which was all about tea brewers, as Mike mentioned earlier. But really, the reason that we started with a tea brewer company is because we believed in compost tea. And we believed that the powers of compost tea being 1 pound or 1 gallon is equivalent to 1,000 to 10,000 pounds of compost was pretty amazing. Because like David said, I first started to get involved in horticulture and gardening when I lived in Breckenridge, Colorado. So it was the same thing David's dealing with, but times, a good amount of altitude. I was growing at over 10,000 feet altitude in the Rocky Mountains of Colorado. And the weather up there was really crazy. We didn't have many options for outdoor. There was a little bit of greenhouse, but it was mainly all indoor farming. So I wanted to focus on the planet, most importantly, because I got with, Queen Bee, which we just celebrated our 12-year anniversary here on April 24th. So I've been with her for 12 years, and I kind of saw a future and potentially, kids in that future and things like that. And I did not want my children, which are now 6 years old, my son, and 3 years old, my daughter, to be growing up in an environment where there's a lot of, environmental degradation, point source contamination, point source pollution, ruined soils, soils that are unable to sustain proper crops and proper yields, a lot of these things were, a lot of information was coming out about the soil degradation issues, wastewater issues, atmospheric contamination issues, and a lot of different issues. So we really kind of started this whole company for the soils, to restore the soils, because we knew that without good soil, we're not going to have proper crops. But also without good soil and proper microbiomes, we're not going to be able to sequester the carbon that's being emitted into the atmosphere from several different industries and factories and facilities all over the globe. So this is really a two-hand thing. It's for the crops, and it's also for the people and for the planet and for the carbon sequestration of our atmosphere. So we're really excited to get involved and to be up here preaching about living soil versus dead dirt, because some people call it dirt. It might be dirt if it's, been dropped off and it's used for BMX or dirt bike jumps or something like that. But everything else is truly soil. We want black, nutrient-rich, microbial-rich, protozoa, nematode-rich soil that has balanced CEC or catalytic ion exchange capacity that allows a lot of interactions between soil and plants and microbes to actually take place. So I could go on this all day long, but I wanted to open it up to Kyle to nerd out a little bit on his presentation that he put together, and then B, with all of you guys and why soil is important to you.
Yeah, so just to give you guys a little bit of overview here about this little thing here that we've got. So the main thing that we're talking about here is these two little arrows that I'm circling with my mouse here. So CO2 being removed from the soil, or CO2 being put back into the soil and resequestering that carbon back into the atmosphere. So we'll start with from the dead dirt side. At the top here, it says that 95% of our food is grown in soil, but 1/3 of the world's soils have become degraded, turning them from living to degraded dirt. That number has been significantly shifted from the point of since this presentation was created. Now they're saying that over half of the soil that we are planting in, and in some parts of the country, it's upwards in 70 to 80% of the soil that we are farming out of is now what we consider degraded or dead dirt. Now, what does dead dirt contain? Dead dirt contains a higher concentration of chemicals. Soils sprayed with copious amounts of chemical pesticides and fungicides have less organic matter than living soil because the chemicals kill beneficial microorganisms in addition to the pests. So instead of specifically focusing on one individual pest and kind of taking care of that problem in its own individual way, most traditional agriculture has gone along the lines of, let's just kind of kill everything in the area so that we can ensure that our crop will have no competition from any sort of pests and things of that nature. And for a while, so it was widely regarded that this is the way to do things. Now, after years and years of doing these types of things, we've realized that this is a non-sustainable methodology. Reason being because there is so much in the soil that, even it's only in the last 30 or 40, some even 50 years that we have even been able to identify, whether it's microbes that we have had to find new techniques in order to culture in the lab so that we can actually specifically see them and realize that their population, or communities of microbes working together where, yes, you may have all the perfect conditions of this microbe to grow, but it also needs these other microbes working in community together with it for it to become established and it to do its job properly. Also, microscopic techniques in order to see very, very small bugs and entomology and things of that nature, like Tate was talking about, like the protozoas of the world, that we have only recently been able to identify, speciate, and realize the importance of them in the network. The network is just like in our communities. It takes a village to do things right. You know, working together is how we are successful as a species, and things are exactly the same way in the soil. It takes every piece of every level in order to be considered a healthy soil. It takes organisms, microorganisms, entomology, it takes bacteria, it takes fungi, it takes all of these things working together in a community, in a diverse community, in order to create the type of living soil that we're looking for here. In dead dirt, there are very few organisms. Soil degraded through massive amounts of chemical inputs and excess tillage contain far fewer living organisms than in living soil. Without these living organisms, soil becomes less fertile, retains less water, which is really important, and is less stable, and then sequesters less carbon. Again, the less of all of these things that we have been fighting against with traditional agricultural techniques over the years, the less capacity that the soil has to even hold on to carbon that we try and resequester back into the soil. Again, it takes all of the individuals, all of the organisms, microorganisms, and whatnot in order to create this sort of effect. And the more chemical fertilizers that are used, the more pesticides, herbicides, fungicides, mildicides, things of that nature that are utilized, the more that it just wipes out those communities from different modes of action. Some pests or some soil bugs may be able to survive an herbicide application, but you put a pesticide application on top of them and it may completely wipe them out. Some microorganisms, some microbiology may even be able to sustain their life through some chemical fertilization, but you use too much chemical fertilization for too long, it takes away the other players in the community around them and it can't support their own metabolism. So again, this entourage effect, this communal effect of building things from the ground up, from the smallest organism all the way up to the largest organism, is what creates healthy soil. Oftentimes, dead dirt has a chemical fertilizer overload. Degraded soils rely on chemical fertilizers to provide nutrients to crops rather than fostering biodiverse microorganisms and the various nutrients that they provide. As a result, soils are overloaded with nitrogen, phosphate, potassium, and develop deficiencies in trace minerals. So again, traditional agriculture has been focused on NPK. That's all they care about. They are so strictly focused on nitrogen, potassium, and phosphorus that they completely disregard the trace minerals and some of the light metals and some of the secondary nutrients and some of the micronutrients that are in the soil. And they don't realize that by overloading things with high amounts of chemical phosphates, chemical nitrates, chemical potassium, things of that nature, that really can decrease the potential holding capacity for these other things that are also completely essential for growing healthy plants. There's less air in a dead dirt soil. Excessive tillage can cause soil to become compacted, meaning it's less porous, so it will absorb less rainwater. High compaction, lots of holding things down makes it very difficult for soils to retain microorganisms and things of that nature. It's basically it's like suffocating them. It's like, instead of having a nice little home where they can create their things, it kind of closes the walls around them and sort of stops them from having the ability to create food and have a metabolism and break things down and do their job properly. Soils degraded through excessive chemicals used and compacted due to excessive tillage absorb less water, making them more susceptible to drought, to flooding, and to non-holding capacity for water. So yes, you may have a whole bunch of water, but how much of that water is able to be held in the soil? Then when, generally, if you think of a soil, when it's dry, it kind of compacts and shrivels on itself. When it's wet, it kind of opens up and allows itself to sort of drain through and have these air pockets in and of themselves. Excessive chemical fertilization and excessive tillage can decrease that capacity, especially if you're doing deep tilling, anything over 6 to 8 inches, you're tilling a foot down, 2 feet down, just to burr up weeds and things of that nature to help with weed control. That may be completely destroying the microorganisms that are in a layered effect. Now let's talk about that layered effect. So the top layer of soil is what we call the aerobic layer of soil. This is where the oxygen-loving bacteria and organisms tend to survive. They metabolize in such a way that they require large amounts of oxygen. Then there's the facultative layer, where it could be either a called a facultative anaerobe or a facultative aerobe, which they can switch between a high oxygen environment and a non-high oxygen environment and metabolize in multiple different ways depending on the environment. And then there's the anaerobic layer underneath of it, which is very, very low or no oxygen containing. Strict anaerobes in the presence of oxygen actually are completely destroyed. So the deeper that you till down in there, it completely messes this layered effect up. Your anaerobes get buried down underneath, and they tend to lose their capacity to hold oxygen. The facultative ones could get dispersed all over the place and end up taking over populations. And then the anaerobes are brought up to that high oxygen environment, and many of them are killed or destroyed. So by using these old school farming techniques that may work for, few years, especially if it's in completely untilled land. Yes, bringing up some of that black earth and kind of turning it around was a little bit more effective than just planting things straight in the ground. But again, when you look at things on a micro level, on a small scale level, and really just look at what's actually contained in those soils, they do much, much more damage than good. So this is why we want to encourage people to the other side of this presentation, which is the living soil. We want you to start by re-inoculating with the most simplest of organisms. We want you to start simply by inoculating with bacterial and fungal populations, the smallest of the small, and stair-step your way up. We also have options like through Arbico, our partner, our entomological partner, and Kara, our bug lady, who can help you with things like beneficial nematodes and things of that nature to help fight against pathogenic populations and reinstill entomological, the next step up of these.
What's happening, y'all? We're here live on Instagram, and we're coming at you with our fun friends.
Living soil contains living
so
organisms.
It's pretty exciting.
Of the world's
is
biodiversity
you guys can also join this live YouTube, Twitch, LinkedIn, Facebook, Zoom, however you want. But we're going to be holding it down here on Instagram Live. If you want to see more detail on what we're showing today and what we're presenting, jump over to YouTube Live, because YouTube Live is really where we're going to be hosting this. You won't be able to see any of our PowerPoint presentations or anything like that from Instagram, but you will be able to hear the nerd bombs that we're putting down, and you'll get to see me doing fun, interesting stuff with my animal friends. So, we're breeders of everything, guys. Plant breeders, animal breeders, microbe breeders.
It's really best to let nature do things and work things out the way
we appreciate you guys joining us.
Which is by
and yeah, like I said, feel free to jump over to the live platform.
Things of that nature. So
you'll see more people over on the YouTube Live than you will on our Instagram.
We can ensure that we have.
With that being said, I'm going to sit back because Kyle's dropping nerd bombs here on the YouTube Live channel. Just wanted to bring this up and welcome you guys into the nerd section.
All of the breakdown of these things, taking plant matter and things like that and breaking it down, taking animal feces and breaking it down. All of these things are important to provide nutrition to the soil, which is why compost works so well. It's just another form, contains high amounts of organic matter. The animal has done, especially if it's a grass-fed or a
what's happening, y'all?
Animal. That's really the only compost we don't want to use. We don't want to use meat-eating.
Jump over to YouTube Live if you want to hear the rest of
like,
what we're putting down.
Buffalo or cows.
YouTube Live, Key to Life Supply, is where the main action is. I'm just jumping on here on Instagram to let everybody know what's going on. So check us out.
That actually are responsible for breaking down that thing in the animal themselves and inoculate those bacteria into the soil so that they can be present to continue to break things down over time. We then in turn, much of this organic matter contains carbon. That's what we're trying to do here, is we're trying to resequester that carbon. So this carbon is sequestered in the soil and in the bodies of soil microbes rather than released in the atmosphere, where it contributes to global warming. So all of this plant matter being broken down, food scraps being broken down, things of that nature, grazing animals that graze on grass, it just grows up and sends it through. All of this stuff is beneficial to what we're trying to achieve here, to get to the point where our soil is a living soil again. Living soil also contains higher mineral content. Living soil contains nitrogen, phosphate, and potassium, as well as trace minerals like zinc, iron, copper, manganese, magnesium, molybdenum, and boron. All of these secondary nutrients or trace minerals are essential for plant growth. A lot of times in the hemp industry, I see people so focused on NPK that they're like, oh, my plants are turning this weird color or having this weird necrotic spots on them, or they're doing this weird thing. Oftentimes when you identify the actual root of the problem, it is a secondary or trace mineral deficiency. And then we need to supplement with something like a plant-based micronutrient, something, we may need to, at the end of the season, or at the beginning of next season, we may want to re-amend with more trace minerals, things like silicates, things of that nature, things like, zeolite, montmorillonite, things of that nature that contain a large profile of these trace minerals. That way when we look at the soil, the next
join YouTube Live.
Report, what's that, Tate?
My bad.
Oh, no worries. So so all of these things together really ensure that, again, when we look at a soil report, we want to look at the entire report. I don't just want to see, PK and pH in a soil report. I want to see all the trace minerals. I want to see secondary nutrients. I want to see soluble and insoluble nitrate levels. I want to see all this stuff so we can get a complete picture of what the soil actually looks like, whether it has the capacity to be a living soil, whether it's most compatible with the nutrient style that we're trying to achieve, whether we need to amend these things into the soil at the beginning of the season so that we can have a fighting chance to not go deficient in the middle weeks of our flowering cycle. All of these things are really, really important. And then the last thing here is the water. Soils absorb and help purify water, benefiting plants and the human water supply. Studies show that living soil may hold at least 10% more water than dirt. And some studies have even suggested that it can hold 25 to 30, even 40% more water, depending on how severely degraded these soils are. Also, it contains air. There are in a true living soil, because the little worms dig through and leave little trails behind them. All these different bugs and stuff like that, create little pockets of CO2 and things like that are actually little air pockets, or CO2 containing pockets that actually are little bubbles basically in the soil. All of those contain to holding air capacity as well. Large air spaces allow for proper drainage. So again, if you're having an issue with compaction, with too much, the whole soil holding together too much, being too dense, the first thing that we can do is use things like humic acids and fulvic acids to mechanically sort of open it up. And the second thing that we do is we implement the biology in order to create over time these sort of natural air pockets and natural soil pockets in the soil so that it can contain proper drainage and have proper nutrient flow throughout, so the nutrients aren't just running off the top and ending up in the water supply as opposed to ending up in the dirt where they belong. So that's just kind of a general overview of what living soil versus dead soil is. Having gone through all of that, does anybody have any questions or is there anything you wanted to add on top of that?
That was a really good overview. Obviously, we could go for weeks and weeks and weeks and months and years with all the different benefits of true living soil and how it truly adds to sustainability as far as an entire planet and really balances a lot of the actions that we as humans really make. But I wanted to open it up for everybody. So who else? Who's got questions? Oh, Mike's going to be caressing us with beautiful strumming today. We're trying to spice it up a notch. Yeah. Boo-boo!
Nobody else has one. I'm clearing overgrown farmland that 50 years ago had cows and corn and
I'm straight chilling with the snake.
Pulling up
straight chilling
the tree stumps, and
we're breeders of everything, guys. We breed snakes, we breed animals, we breed peppers and tomatoes, we breed cannabis and hemp, We
done that
breed
by
all
clearing
sorts
the
of
land.
stuff.
And
We
now I
love
have
God's
what
beautiful
I
creatures.
perceive to be
Join us on
2 layers of
YouTube
soil.
Live. If you can see me from
You have
here,
granite
the main
outcropping.
presentation's going down on YouTube
On top
Live
of
on our
that
Key to
is
Life
a
Supply
thick
page.
clay-like soil, doesn't drain, heavy sort of stuff. And on top of that, I have a layer of what I would call composted pine needles. There are a lot of pine trees here. It's a completely different color. It's sort of a rust color. It's very fluffy, if you will, completely different texture. I think that's more of what you were referring to as a living soil. And then I have 3-year-old composted worm castings. I got my neighbor's horse manure and put earthworms into it. And my plan was to rototill the 2 layers I have, mix the clay in with the top composted pine needles, and then put the worm castings on top. And my question is, should I rototill those worm castings into the lower mixture, or should I leave it as just a top layer alone? You know, what is the best approach because I'd like to do this once and have the soil in the best shape permanently that I can get it. So I'm looking for advice on what to do now.
It's actually
So generally your worm castings are pretty heavy. A casting sort of compost is fairly heavy. But if your goal is to more homogenize that sort of broken down pine needle layer with the deeper layer that's generally more compacted, generally a little bit more difficult to hold on to moisture and something like that, my suggestion would be to first sort of go through and do like you were talking about, sort of blend those 2 layers together as much as you can. That way that some of that more living soil can kind of break that barrier where it's not just your aerobics and your anaerobics. We've got that sort of peppered layer in between of our facultative microbes. So kind of bring those 2 together, and then at the end, put your castings on top and only lightly till them in, just enough to, I'm talking like a 1/2 inch to 1 inch maybe, to just sort of get them married in with that soil that's kind of already there, that sort of blend between the 2 of them. What that's going to do for you is it's going to ensure that you don't form like a real thick, crusty layer, because if those the castings ever really dry out, they're going to turn into a brick like that. And that's going to cause drainage issues. That's going to cause moisture retention issues and things of that nature. So if you can blend those 2 bottom layers together a little bit, fill on top, and then blend that worm castings in a little bit with that newly blended layer, that should give you the best opportunity to start with. On top of that, I would also definitely recommend inoculating with some beneficial microbes, some beneficial fungi and things of that nature, so that you can start the building blocks. Because by doing a lot of that, like you said, the stump busting and the deep tilling and the de-weeding and the this, that, or the other, you already disturbed that sort of biological layer. So you just kind of have to start back from square one. You got to start with your microbes, you got to start with your fungi, and you kind of just got to get that all in there. A lot of the worm castings is going to contain your beneficial bacteria. It's going to contain a higher percentage of organic matter. It's going to contain a lot of these things that we're looking for. That's more along the lines of living soil. The trick is to get it slightly married with the soil that you already have there, so it doesn't either just run off with your first rain, large rain, and just end up in the ditch somewhere else. But also to ensure that, after that's been done, that we come back again through and re-inoculate with the proper bacterial and fungal population as well.
And how do you inoculate that with the proper population? What is the process in the product, please?
There's a couple different ways that we can do it. Either we can, when you do your broadcasting of your castings, we can apply that the sort of bacterial in its carrier, along with in its dry form, and then as it's tilled in, it'll sort of break from its carrier and move all the way through. Or if it's a possibility for you, something just like a watering tank that you pull behind a tractor that kind of sprays and mists down over that soil, just run that through your field as well after you've done all of your tilling, and allow that to saturate and to sink into the soil. You know, and then if you're going to be planting out into the field, that's another good time to do it as well. Especially if you have like a water wheel that you're planting with, where you're just, you know, it's kind of dropping the thing in and it's squirting it with something and following it up in between. That's another good time to add those inoculants to the soil as well. Again, you're going to have a lot of them in the castings that you're already in the compost that you're already going to be applying. It's just good to sort of bolster that population with a lab grown, mainly, you know, specifically tailored set of organisms as well.
So the question arises, if these organisms are lab grown and tailored, is it geographic, weather?
Join us on YouTube Live. If you're like, why is there just a room sitting there with a guy that might be, well, the real presentation's going on YouTube Live.
So
come join us. Key to Life Supply YouTube channel.
So when we tailor them based on their role in the system. It's kind of and I hate to use this word.
And we'll do dabs in the meantime.
Type culture. What we're trying to achieve is
And I ran out of this one. It looks like
fixation and delivery of nutrients. That's what we're trying to achieve here. So some of them are mainly meant to take what's already in the soil, break it down into a more simple level that's more biologically available. Some are tailored specifically for fixation, where they take things like atmospheric nitrogen and fix it in an organic way. You use the metabolism of the microbes to specifically fix that nitrogen and put it into an organic form that can then be uptaken by the plant. And the third one is the delivery. Some are specifically meant to help deliver and mobilize nutrients in the soil. So no, there is, if that were the case, there would be a different microculture for every 200 yards across the entire planet, if we really wanted to look at it that way. So what we've done is we've again
join us YouTube Live. If you're like, hey, what's going on? Why is he just sitting there? Join us on YouTube Live, and you'll see the real presentation going on there.
They're different from, you know, elevation to elevation. Down a single slope of a hill, there can be a different microbe level every 2 or 3 feet, based off of what's natural and innate and been produced in the soil over time. So when we tailor our microorganisms, we do so again by task. So we ensure that we have all of our bases covered, that it covers nitrogen, potassium, phosphorus, calcium, sulfur, chitin, chitinase, secondary nutrients, micronutrients, trace minerals. All of the nutrients are covered, and then the function by which all of them are applied, again, whether it's fixation, mobilization, or breakdown, all the players are there as well.
Hey, Kyle, can you hear me now?
Yes, I can.
Hey, I got it working.
All right.
Well, first I want to say bravo. You know, I've been studying this stuff a long time, and excellent how you've explained it. I loved it. I have a question about David's application with this turning he's been doing, and all the, you know, up to the gentle mixing and the work casting and the top layer. How long would you say it'll take him for that soil to become balanced and stabilized? Is that going to take more than a growing season or two, or?
Generally, I like to say, you know, especially refurbishing projects and projects where we're trying to rebuild soil and we're trying to regenerate things, it can take anywhere from 3 to 10 years, depending on how severe.
What's happening? If you guys can see me sitting here, what I want you to do is jump over to our YouTube Live. YouTube Live is where everything's actually going down. I'm just kind of sitting here where we tried to tee it up. We tried to have our Restream software join our YouTube Live, our Facebook Live, and our Instagram Live all together. Instagram is being weird, so here we are. I'm just hanging out with you guys individually, but if you guys want to see the real presentation of what's actually going on, jump over to YouTube Live. Go to Key to Life Supply YouTube and go to our live section. It's going to be where you're going to actually see everything that's going down. And yeah, that's where we'll be talking about key to kelp, because it's a fire. We got you.
There are generally areas in general, places like,
and I'm gonna be real with you guys.
And,
we need you guys to show us some love right now.
coast,
It's been a weird freaking year. Hemp industry exploded.
Like,
Cannabis
Colorado,
industry
is
is on a rise, but people are still skeptical of another crash. Freaking coming out of a pandemic. It's been a tough year. It's been a freaking hard year. That's for sure. If you'd have told me in 2019 this was going to happen within the next 12 to 18 months, then I would have been like,
what about a mulch layer? Just a, like, not really a living above the top layer.
But guess what
like
had happened?
Blanket,
And the world exploded.
Possibly, we call it in the
exploded.
urban forest where I work more with the trees. The mulch is like a blanket for them to keep the soil warmer in the winter and cooler in the summer. It holds in moisture. And if it's right, it's layered similar to your soil layers, and you have the active, black Duffy pine needles and such right at the top of the soil layer, and then up to where it's just pine needles. And it's really not active. It's the fresh stuff each year as a blanket. Do you work with that kind of upper layers as well when you're doing a no-till kind of a process?
Mulch layering is, especially on a commercial scale, can be pretty difficult. On smaller scales, it can be effective. What I find oftentimes is, unfortunately, the mulch that is being provided is inconsistent. It's generally highly acidic as well, which is not conducive to aerobic bacterial growth. That oftentimes fosters more anaerobic bacteria.
What's up? So, join YouTube Live. We're on YouTube Live. That's where the main presentation is at.
Sorry. Yep. Thank you, Tate.
Oh, my bad.
Sorry,
I'm talking to Instagram over here too, so I'm trying to mute and then unmute and then mute, and then I'm streaming in too many places. Sorry.
It's all good. Beast, right? But yes, there is definitely some efficacy to, especially in the first couple of years when you're doing this. That sort of blanket and that insulating layer can be incredibly beneficial especially in areas where there's lots of temperature fluctuations and things of that nature, and it's not really meant for high productive cultivation. A lot of the areas that we're talking about here, they're trying to produce a crop, be it hemp, be it whatever they're happy to be doing. And a lot of times that mulch layer can be anti-conducive to nutrient allocation and movement. But if it's just a restorative thing, like you're again trying to restore a forest, trying to restore a plot of land, and you're not trying to produce on it, that mulch layer is definitely a lot easier. It's good for weed control. It's good for moisture retention, because a lot of that mulch generally does a good job of the top will dry out and then it'll sort of layer down as it dries through, as opposed to just drying everything and turning into nothingness. So there's validity in either direction. It just depends on what you're trying to achieve from your field that year. Again, if you're going for super high production, I would more rather see you do something like a clover cover crop, something that's going to have a really nice area of roots that are kind of going to break open that top layer of soil. You can till it in at the end of the season. It can have that same sort of insulating effect, but it's doing more nitrogen fixing. It's doing more breaking apart of the soil, and that way you can grow your tall, because it only gets up to about 8 to 12 inches, and then it's about as tall as it gets, and then you grow your high.
Unless you've got clover like I had in my backyard last year, which was freak of nature clover that ended up being like almost 3 feet tall.
Densely as well.
Yeah, but it was also like 2.5 feet tall as far as clover. But what I wanted to also add for you, Deborah, is that you can kind of combine the two methods. Like, for instance, this last year, like when the winter snuck up on me, I didn't get to take down my cover crop. I didn't get to till it in. I didn't get to remove a bunch of the skeletons and dead plant material from a bunch of my other plants. And I didn't get to remove any of the fall leaves from any of the trees or anything like that from the beds as well. Well, it's funny because me and my wife went out and we've been doing garden preparation stuff like the last few weekends, because we don't get to really plant out here in Colorado until like June 1st, or you're going to guarantee get snowed on. Yeah. And so basically, like what I did is I kind of combined the two. And it was funny because as we were like cleaning up the beds of all the leaves and all the like pine needles and all the dead plant material from the previous year that traditionally I would have tilled in or cleared out before it wintered, it really like benefited this time. Like the mother nature prefers laziness. I swear. It's because that's the way of her systems. You know, that's the way of her systems.
Mother Nature's relentless.
Yeah, you know, and so like I found like the less you do, almost the better. It was funny. I still ended up, you know, cultivating my garden and like clearing out all of the dead plant material. But as soon as I cleared away the dead plant material and the leaves and everything, I saw, oh nice, area 420 in the house. I saw all the cover crop starting to pop up. And then it was beautiful because about 2 weeks later, after that cover crop popped up, it was about 1.5 inches tall. And I came along and did all my like amending, my first round of amending, which is all my like really heavy NPK nutrients. Like for instance, I put down a 125-0 bone meal. I wanted to allow more time for that to break down. So I did a first round of amending, which is going to be the bone meal, the blood meal, the bat guano, the humic, fulvic amino, shale, the rock dust minerals, and things like that. And then that, with all of that cover crop that had popped up, you get a retill, kind of like what Kyle was bringing up, where you can blend it or till in the green cover crop and add that nitrogen back to your soil. I kind of got that by clearing the soil, allowing it to sprout, adding nutrients and amendments, tilling it all together. And this weekend, I'm actually going to go back and kind of do what David was talking about and add worm castings and vegetable-based compost and further rock-based minerals and volcanic ash. So like it really is a multi-step process that you can also combine with Mother Nature's processes as well.
Yeah, so what you're saying there, Tate, is that leaving the sort of the dead skeletons and the things of that nature over winter kind of already did that sort of like a mulch layer would do, and protected
it stabilized
that top layer of soil.
Correct. Yeah, that very top layer of soil had no dryness to it. It was moist, and which means there was a lot of microbe populations still. Versus since then I've scraped the top of the soil of all those skeletons and dead plant material, and that actually kind of dried the very top layer of soil out just a little bit. And therefore, you know, that little bit of dryness then I feel needs to be tilled back in and the cover crop reestablished to protect it and maintain moisture levels, which maintains microbe levels.
Just keep those organics there.
Right, totally.
When in the arboriculture industry, growing trees, it's highly advised to keep those leaf litters, you know, in a reasonable form. I'll actually mow over it with a lawnmower,
right?
Mulch it in, and then sprinkle some fresh pine needles or some chips or bark chips on top, and it looks nice because I work in the urban forest, like I said, private properties. So it looks nice, and you're keeping that mulch layer, and you're fire safe. That's my big thing, is being fire safe. And it's hard to convince people that you've got to keep that organic layer to be fire safe. They think they need this dead dirt, no fuel, no fire, and we're ended up with the same thing in the forest: is dead, degraded dirt, and the trees are dying.
Right.
So it was just wonderful to hear this. And I want to add that I just came from Kyle's dad's place, and he was very proud, Dale, my brother, to show me his strawberries.
Oh, yeah.
He just weeded before I left, and I saw some leaves on a strawberry bigger than I think I've ever seen. Dark, rich green, and he's very proud of it and excited to see the strawberries he gets to share with the nutrients you gave him, Kyle.
It's absolutely amazing. Like this last year, I went to my parents' house, and my mom uses it on random stuff all over her property. She had these iris flowers that were like the size of dinner plates. It was insane. They were like this freaking big. Like they're straight up the largest irises I'd ever seen. And they were 4.5 feet tall.
Sustainable packaging.
Excellent.
Sustainable packaging.
I have a question.
What's up, Andrew?
Not to change the subject too much.
It's all good.
So my application is a little bit different. It's indoors. So, and I know I'm not really necessarily starting with, or maybe I am starting with a I can do, or does this really apply to, are you guys still with me?
Yep, we're here.
We got you.
Okay. I thought I was losing you.
It's all good.
Does this really apply to the indoor application? And also I use fabric pots. So is it possible to get those organisms that need an anaerobic environment, or is the fabric pot kind of detrimental to that?
I grow personally in fabric pots. I have half the raised beds in my backyard are grassroots fabric pots. And what I like to say there is oxygen, going back to what Kyle was mentioning with, oxygen level access, referring to the anaerobic or aerobic microbe dominance or balance. I think that fabric pots definitely increase aerobic microbe communities, and it also increases root pruning. So I think that there's a lot of benefits with them. Now, obviously, as you mentioned, one of the biggest things that you got to change when it comes to fabric pots, as well as air pots with holes in the sides, is you need to adjust your irrigation frequency. It's at that point really all about a small amount of volume of water in high frequency. And that is what will get the soil to open up and act like a sponge, like Kyle was talking about earlier, to where it actually opens up the pores of the soil and allows water channeling in a lot more pores and even absorption of that water throughout the fibrous material. And so two things that we always want to remember when we're talking about living soil versus dead soil, and this is kind of a cherry on top to your question, is BSA, which is biological surface area, being like if you took a stainless steel table and inoculated it with microbes, how many microbes are you going to grow versus a piece of shag carpet that's 2 inches tall? You're going to get a lot more microbial community on the shag carpet versus the stainless steel. That's because there's biological surface area to that material. Well, it's the same way with peat and with cocoa and with hemp fiber. They have a lot of different relationships with their fibrous or waxy parts of their structure. Like, for instance, if you look at peat under a scale or a microscope, you'll see a waxy coating, and it's like a cylindrical shaft-shaped hairy object. Versus if you look at a cocoa fiber, there is no waxy layer, and the fiber material has a lot more pores that allow it to absorb water, which is why cocoa absorbs water so much better. It all goes back to what the specific fibrosity structure of that particular fiber looks like. And then the other one is, so there's biological surface area, and then there's specific surface area, which is SSA, which refers to the same basically concept. How many golf balls and surface area of those golf balls could you fit into 1 cubic foot square versus soil or sand? There's a lot more specific surface area, and the specific surface area relates to the biological surface area. So,
Okay.
yeah.
Okay.
Did that answer your question?
Yeah, I think it did.
Okay.
So,
Just a cherry on top of that, Andrew, as well. So if your question is, can I use biology in an indoor environment using fabric pots and what I'm trying to achieve? The answer is yes.
Yes.
Very simply, yes.
Yes.
Totally, the things you're trying to achieve. Being able to inoculate with the proper bacteria, have them do their job, which is, fix things and move things and make things broken down a little bit more, can all be achieved. The tricky part with the indoor situation is what we notice a lot of times, it's not quite, it's effective. It can be utilized. It totally works. A hybrid system where you're using some salt-based nutrients and a lot of organic inputs can be very effective for high yields. The only drawback to it is there's a lot of ambiances to actually how even these microbes utilize light. In an indoor setting, we're trying to mimic the outdoors. That's what we're trying. We're trying to do, have control, but we're trying to mimic the outdoors through, full spectrum lighting and air movement and fresh air and these things like that. What you might notice is it might not be quite as effective in an indoor setting because the light isn't as broad spectrum as an outdoor light. You're not getting nearly the infrared or nearly the things in the opposite directions outside of visible light that a lot of these microbes actually tend to utilize. Now, again, does that mean it's not going to work? Absolutely not. It's totally going to work. It's totally going to provide benefit to you in an indoor setting. You'll see higher yields and higher level plant health and things of that nature. But a lot of times too, in an indoor setting, you're not reusing your soil. You're kind of throwing the soil away every time. And this it can help, but what you're basically doing is you're spending all this time building it up, and then you're throwing it away and you're starting from scratch. And you got to start from scratch the whole next time. You got to try and build it up. And by the time you harvest, you're throwing it all away. So that can be a little bit more.
Join us on YouTube Live.
The
main presentation's going down on YouTube Live.
We're going to build up and build up
Yee.
and build up and build up and build up. And then it's going to get to a certain point where you only have to input very little in order to achieve what you're trying to achieve as far as nutrient availability and nutrient allocation. You only have to add a few things here and there. So that indoor is a little bit more difficult because you're turning over all the time, but you still will see benefit.
Okay, because that was going to lead me to, you kind of already touched on it, but my next question was going to be, if we put so much effort in and obviously cost into building up this soil, is there any possibility with it not being detrimental with you reusing it or letting it cool off, kind of recharge or compost on its own and possibly reincorporating that?
What's happening, brother? Jump over to YouTube. We're going live on YouTube. Key2 Life Supply YouTube channel. That's where we're actually doing a living soil versus dead dirt nerd session presentation. So yeah, check it out. We're just hanging out here on Instagram as well because our restreaming software did not work.
I wouldn't recommend just
it's all good.
Taking a plant.
We're figuring it out as we go. The hustle goes. We just chill.
Different nutritional needs of the plant based off of its life cycle. We've had plenty of people do this, but it takes time, it takes space, and it takes practice. You basically have to do is you have to take them out of their container, remove the skeleton of the plant that was in there, and then take those containers off to the side and blend them all together. Let them sit for a while. Inoculate them with things like a microbially based enzyme that can help kind of knock down some of the salt value, rebalance things out in the soil, add things like biochar to help sort of pull away some of the imbalances and grab some of those free radicals and things that are kind of flying around that could be potentially detrimental. And then test it. You want to be, before you go sticking a plant in it, I want to know what's in that soil. I want to know the nutritional value. I want to know, what's.
Hey, did you guys make the jump over? Anybody who's on here that jumped over from Instagram, let me know, because I'm seeing what my conversion rate is. That's why I'm doing this crazy thing. This means conversion rate. So let me know on a conversion rate. And so just so you guys know, in the future, we are going to be doing this all through YouTube Live. This last time we tried to do it on Zoom.
Once you get the flow of it figured out,
Had
it is immediately
difficulties.
same
We
things over and
also
over in the
tried to
same
do it on
plants, and the same
Instagram,
nutrients
and
the same things.
Instagram had some
Eventually, you're gonna figure out,
difficulties,
like, okay,
but not
every single
really.
time
But
I've
kind
got to
of,
wait this
but
long
you know.
for this to cool
So
down. I got to
if you
wait
guys
this
could
long
throw
for this to
something into
go
the
back
chat,
in,
let me
you
know
got this much of this in
where
there,
you at.
and it'll be a little
That'd
bit
be
more
dope.
of an easier process. But it will take you some time to get there. But it is 100% possible. It just, like I said, it takes time, it takes space, and it takes some practice.
Okay. Yeah. I mean that. Okay. Sounds great. I think you answered everything.
Yeah, Mike. Woo!
Absolutely. Thank you for the question, Andrew. We really appreciate it. Does anybody else have any other questions about rebuilding soil, reusing soil, dead versus living soil, some situations that they've run into? Hey, I'm using this. Is this going to harm what I'm trying to achieve? Anything along those lines? Any questions anybody else may have?
Here's what I always want to say on.
Question.
Oh, Kara, go
Yes,
for
Kara.
it.
How should you like alternate certain products? Is it, I guess, does it just depend on like what your goal is, I guess, or can you do all of it at once? How frequently? Like, kind of go into detail of that.
So when you mean certain products, like a nutrient versus a supplement versus an inoculant, like what types of products are you talking about?
Obviously, you kind of have to figure out what you're working with, but should you stagger, like doing one thing at a time, or should you try to do like a combination of things all at once? Like what kind of should you be focusing on if you have, dead dirt and you're trying to build it? Like, what should you first do, or what kind of combination should you do if you're just starting out?
So, so the first thing is to take a look at your blank slate, take a look at your soil report and see what you've got. Second thing would be to purchase the products based on what you're trying to achieve. So like, let's say like the meal products that Tate was talking about, things like oyster shell flour and bone meal and things of that nature. Some of those things can take 8, 10, 12, 16 weeks to become actually physically biologically available. So the best way to really do it is to kind of curtail things in that nature and understand that. You use a combination of things. You at the beginning of the season, you take a look at what you got. You put your meal products and things of that nature, and you do it with a strategy that some of the things that you're going to apply are going to be immediately available. Some of the things that you're going to apply are going to be available after a couple of weeks. Some of the things you're going to apply are not going to be available for, again, a couple of months. And you sort of you kind of pre-amend at the beginning of the season and do your best guess to get as close as you can, so that your nutrient availability kind of goes like this, and it kind of just floats right in the middle. And it's not ever just doesn't ever really. Sorry about that. Oh my God, mute. Sorry about that. So it kind of it floats right in the middle. We want it to to never really just like spike super hard and then dive down really hard as far as availability. So you can get it pretty darn close if you've got a good strategy with that. However, the first time you're doing it, especially from a very dead soil, things may change. You may get a couple overly wet weeks where a lot of that stuff can kind of maybe even wash away a little bit. Some of it can become a little bit more available a little bit sooner than you do, because you might overdo it a bit with the biology and it becomes available a little bit quicker. So it may take you a couple seasons to see that sort of that even flow. Your first year, more than likely, I hate to say it this way, but you're probably not going to do it right the first time. You're probably going to have something that you're probably going to go deficient in some section, and you're freak out and you're like, oh my God, I need a bunch of nitrogen. So you're going to apply a bunch of really fast available nitrogen. And then by the time that's available, then the stuff in the soil becomes available, and now you've got too much and you've spiked way too hard, and now you're nitrogen burning things. So it's it takes, like I said, it takes some practice, it takes some delicate hands, but you can do a lot by just taking a look at that report and kind of strategizing, okay, this is going to take this long to become available. I need to ramp up my biology during this week because I really need to make sure that during this 2 or 3 week window that these certain things are available, because that's when the plant's transitioning from this phase to this phase. So it's a combination of all of it.
But also,
some products that you use all the time. There's some products that you use at the very beginning. There's some products that you like their humic and fulvic acids. We alternate dominance of humic and fulvic acid on a bi-weekly basis, so that we can get everybody on the bus and we drive everybody where they need to go, and then we get everybody on the bus and we drive everybody where they need to go.
But also there are also some ways, we don't want to get you guys intimidated. There are some ways to buffer and limit some of your liabilities and your risks as you are building your soil. First off, doing what Kyle's talking about, knowing what your canvas has. Second off, balancing your approach, making sure that you're applying potential equal and or formulated ratios of NPK micronutrients, but also carbon to nitrogen ratio. Also aeration to drainage, and also compaction levels. So like, as we're doing this, we can just look at really good soils, and by doing the smell, the feel, and the drain test, we can also limit a lot of our liabilities. And a couple other things that we can do to just add renutrification to our soils, but make sure that we're not overdoing it and add a buffer value, is things like biochar, as well as compost and worm castings. It's really, really hard when you're adding equal parts of compost and worm castings, as well as green material like alfalfa meal, and aeration like perlite or pumice stone to soil, and making sure that you keep your aeration levels up. It's really hard you can throw a lot of other variables at it when you throw compost at it, and it equalizes a lot of the playing field that you're working with. If that makes sense.
We haven't really talked much about biochar today, but I think it's a really important thing.
Maybe that's what we should do our next
one.
About
with the mulch layer kind of being your protective blanket in the soil, biochar kind of acts like the same thing. It's basically, it's something that if there's something that's way out of whack and in high concentration, like whether it be a harmful heavy metal like arsenic or something like that, or whether it be a salt value or something like that, biochar does a really good job at sort of kind of putting its arm around it and grabbing it, so it doesn't just go crazy and let loose and become super available. It kind of holds everything. It basically looks at the whole canvas and says, that's way out of whack, let me grab that. That's way out of whack, let me grab that.
It's an equalizer.
It just sort of self-balances and self-equalizes things in the soil because of its, again, it's just free carbon, and carbon does a great job at grabbing onto overly active radicals and things of that in the soil. So again, it kind of helps provide that sort of buffer, that sort of blanket by which we can make sure that nothing goes crazy out of whack too quickly, and insulate yourself a little bit against any of that free radicalization.
And with that being said, shall we show a video of biochar and me amending biochar into a bed this last weekend?
Sure, I will stop sharing and go right ahead, Tate.
Cool. So share screen. You guys are going to get to see my little backyard setup. Let me get it brought over here. Boom.
What's happening, y'all? We're out here with the biochar. The ancient secret.
Sorry, what was that?
Did you do sulfur and then biochar?
We did sulfur, biochar, bone meal. I also threw in some revitalized amino acids because I love having super available nitrogen in my soil, and the aminos stick to the fibrosity and the BSA and SSA of soil really, really well. And then I'm actually picking up some worm castings later today or tomorrow morning, and some veggie compost. And I also am throwing in a bunch more like volcanic ash and rock dust and rock phosphate and green like alfalfa meal, kelp meal, and fish bone meal.
Nice.
Yeah.
This stuff it is fluffy as it gets. It's the best biochar ever. Ancient secret. Check it out. Made from pine beetle kill here in Colorado, and not only is
This was before tilling, so I go and till all of the biochar and the green in all at once.
Carbon emissions and hydrocarbons don't go in the atmosphere from the trees being burned, which are a part of the pine beetle kill, which is about 42 million acres of wood that's affected by this bug. But we turn it so we prevent those emissions from escaping into the atmosphere. But we also add it back to our plants, which then, as the season continues, there's a good amount of carbon sequestration, not only through native soil biology, which native soil biology can be boosted by up to 1,000% when you are introducing carbon into your soil, like this biochar, because every teaspoon has a football field of surface area for microbes and nutrients to cling to. It also balances soil relationships with other nutrients, and it also allows for a good amount of water savings. We used this product back in 2014 on a neighborhood here in Colorado, the Cherry Creek Golf Course neighborhood area, 3 neighborhoods. In just 3 months, we saved 3.3 million gallons of water. A lot of threes there. It's kind of crazy, but it's a really huge benefit for our planet and for our gardens as well. As we remember, all the Indians and the Mayans layers of terra preta soil are the most nutrient dense and microbial dense soils on the planet. So I like to take it back to the old school when it comes to organic gardening. Check out Ancient Secret and Biochar.
Hi, Daddy.
So dirty.
I'm playing with my
What's
friend.
happening, y'all?
Yeah, dude, I'm live right now. Sorry, Tegan came down. But yeah, so there's a little nerd rant on some biochar. More to come. We did a lot of, actually, Kara asked what I was using, so I'll show this real quick.
We're in the backyard getting our amend on, getting pretty excited. One of my favorite things to add to soil is aminos. The Revitalize just crushes as an amendment because it just boosts all your microbial activity super hard. Your plant available nitrogen, so right as you plant into it, everything just loves life. It's awesome. Then of course you got to throw in a little bit of that old school bloom. The bloom has a bunch of humic, fulvic, kelp, and mineral, like rock dust minerals in it and whatnot. Then I always like to bump in some extra kelp, extra fungi for sprinkling in during transplant, as well as during your bed amending. It's never bad to just sprinkle it in super light. Molasses magic, once again, add some heat to your soil, get it alive. The exact thing you're going for with pre-season amending, and crank it with some elemental sulfur. Yee!
So here we are. We're past the hour. We're 20 minutes technically past the end of what we were supposed to do here today. That means we're all interested. This is all things that we love. We're all into gardening, sustainability, saving the planet with our soils, and having better crops for our families in the process. That's what it's all about. So
I had one question about cover.
Yee!
Kyle actually helped me answer this, but it was from one of our farmers. He's growing in 200-gallon pots, fabric pots, and they did a cover crop. They did oats and legumes. Am I saying that right?
Legumes.
Yes. Legumes. And so the oats, they took off, but the legumes did not at all. And so now that they've got this like oat grass, whatever, they're asking, from what he's read, basically that those oats will just continue to suck up nutrients off the top layer, and that those nitrogen fixers like our aminos wouldn't really take off. Or those nitrogen fixers like the looms, they didn't really take off. So what should I do? Should I till the oat grass in, or should I cut it off and throw it away? What do you do with oat grass?
At this point in the year, what I'd recommend is, because also it's always about temperature with these pre-season cover crops. like temperature is a really, really sensitive thing that can either send your seed back into dormancy or it can wake it up, as well as plant available nitrogen, plant available water. A lot of different variables come into factor for seeds deciding if they're going to wake up or if they're going to go to sleep for this year. So my recommendation would actually be to till it in with some compost and then reapply some clover seed. Is really what I'd recommend. It always comes to how big, what scale are we dealing with? Because we always have to adjust the solution based on the scale. If it's my backyard, that's what I do. If it was a farm and 20 acres, I'd probably do something different.
It's about 3,200 gallon pots.
3,200 gallon pots. That's a huge pain in the butt. Yeah, but that's a lot of individual containers. Okay, so in that particular situation, has he planted his main plants yet?
They're still propagating.
They're still propagating? What size plant are they planning on putting one plant per 200 gallon?
Last year we didn't, and we had some mold issues and such like that, which we're trying to fight off with like Regalia product, and I've talked with Kara a little bit about beneficials and such. But yeah, we're just to mitigate any risks, we're just doing one plant per large plant per pot.
Yeah, okay. So what I would say is here's what I would say is I would actually amend my soil. If they have any amending they need to do, have they amended yet?
We've got silica from Key to Life. We've got microbes and fungi.
Anything heavy like a compost or a worm castings.
But they also have some glacier rock dust that they're going to amend.
Yep.
Some of our silica.
But no worm castings or compost?
I think there was a blood meal that they wanted to put in there. They could get source pretty cheap.
Compost or castings?
So no.
So yeah, basically, so yeah, basically, that's what I was. That was my escape route. That was my escape noise. I'm just joking. But yeah, so what I guess kind of what I would say is I would come through there and I would re-amend the topsoil. They're going to have a lot better results if they use this opportunity to add compost, manure, or vegetable castings, or the combination of all three.
Something heavy and dense.
Something heavy. It's like another soil, soil builder, right? A soil builder, soil amendment style. Once those types of things are added, then they're going to be able to incorporate a new top cover as they choose and a new cover crop as they choose, and it's going to take off. This thing number 2 on that is if they wait until they plant to reestablish their cover crop, they're going to be able to use the shade from the plant itself to help establish the cover crop. It depends where they're at, what their weather patterns are. Here in Colorado, I don't need to worry about that. My temperatures are fine. I can lay down clover or any other type of cover crop, and I don't have to worry about the shade problem, especially if I'm doing it while doing any type of amending and mixing it into my soil, even just slightly, and doing a scratching.
And you'd recommend like a clover over oats or legumes?
Definitely.
The oats grow vertically way too fast.
It's going to compete against your crop.
And again, at this point, your legumes that you've planted there's no chance for them because the oats have completely taken over. The legumes that you've planted they didn't get a chance enough to kind of grow up and vine over the top of the surface and allow the underneath stuff to start growing. So they're pretty much toast. So like Tate's saying, at this point, you're stuck with either bust out the weed whackers and whack that stuff completely off, or
tiller,
so it's not 4 feet tall by the time you go to plant your plants in there, or put something heavy on top of it, cover it back up in the ground, get it all covered back up, then plant a light layering of a different cover crop of a different kind on top of that, then plant your plant in and amongst it. So at this point, especially if the oats have taken off completely, you kind of shot yourself in the foot there a little bit. So you're
back in and it's still going to be a nitrogen source instead of sucking up nutrients.
Yeah.
If you till it back in and cover it with some castings, something heavy like that, yes, it will have not sapped all of those nutrients out of the soil completely. It will have converted them, and it will need to take some time to turn that plant matter back into something that's bioavailable. But yeah, if you just whack them off and take them all out, you will see some nutrient loss in that container.
Yep.
Okay.
Yep.
Cool.
Yeah, and actually the reason that we always refer to clover is because clover does not pull that much nutrients from the ground. If you time it correctly, it doesn't compete with your other plants. Now, that's all about timing and crop type. Last year, I had clover that was freak of nature clover that was like larger than my hand and like 2.5 feet tall. And it competed totally against my plants, which I never thought that was going to happen. But,
certain types of plants, like the tall plants, like tomatoes, it didn't really mess with. The cannabis plants, it didn't really mess with. But things that take a long time to get vertical, things like peppers, things like, stuff like
onions.
That is the stuff that it competed with.
Yep.
Good to know. Thank you.
White clover, white flower clover.
White clover, crimson clover, or red clover. Any three of those I would recommend.
Yep.
Well, I think we're pretty well past it. Does anybody else have any other questions, or should we wrap it up until our next session? Oh, quick poll, anybody who's here. Of the things we talked about today, is there something you would like expanded on more that maybe we could make the topic of our next discussion? Like we could talk all day just about biochar if we wanted to. There's plenty of.
I say biochar.
Yes. Also cover crops.
Yeah, I'm a fungi fan myself.
Oh yeah.
I worked with mycorrhizal associations back in the mid-90s at the University of Riverside in California. And
That's
so
awesome.
It just warms my heart to see you young people talking about these important soil aspects. I mean, I feel like I've succeeded myself just in seeing this,
That's awesome.
Finally coming back around.
Well, good job. Yeah, no, we are stewards of the soil, and anything we can learn. Like, actually, you inspired me. Let's do biochar, microbes, and fungi.
Very good. Okay, I wanted to leave you all with a documentary too. I just saw. It's narrated by Woody Harrelson, and it's called "Kiss the Ground."
Oh yeah, I've seen it.
Just like this meeting today, it just success. Finally, there's more information out there, more people understanding this. It's ancient wisdom, and we're just bringing it back from the, giant farms that had to sterilize and fumigate the soil to control it, and trying to control Mother Nature instead of working with her. So bravo.
They only thought the soil was there to hold the plant up and down. It's mind-blowing. When I heard that one for the first time, like a decade ago, I was like, this is a thought process that certain people have. And they're in charge of our food supply. What is going on here?
Well, a lot of people still think carrots go straight up, or think trees go up like trees and down like carrots. They don't realize how much the roots go out.
It's a mirror.
People talk about how the forest communicates with itself, and a lot of that is those fungal associations. That's the hyphae. And when you talk about the biochar and all the surface area for holding on to things, well, in the associations of those mycorrhizal hyphae, that provides surface area for the roots to uptake the water and nutrients as well. So you find the capacity of a tree to be able to do that, bring up nutrients and water with and without the fungal associations, it's profound. It's like 2/3 more.
Yeah, I would say it's probably like 10 times more.
There you go. Yeah. And they're different kinds. Of course, the trees have a different kind than you're talking, probably more about the vesicular or muscular mycorrhizae in this application. But yeah, it's essential. I don't think the essential aspect of that has been understood as much until.
Yep, no, you're correct. And actually, I have this fun little video that I'm doing right now. And it's called The Biological Network. And it's all about our soil and the root systems and the chain reaction of life.
It's even a little hot seed. I love it.
I don't even know if anybody on Team KTL has seen this. Oh, that's the sneak preview. That's the sneak preview. We'll show more next time.
Well, thanks everybody for joining us. We really do appreciate your participation and your interactions, and your feedback is absolutely essential to us. We are planning on doing one of these at least every 2 weeks in perpetuity. So again, any topics that you guys want, thank you to all of us who joined us on YouTube Live and Facebook Live and all of our streaming platforms that we've had been on today. We really appreciate all of you as well. And we look forward to doing more of these and continuing the goal of educating everybody around us to just be better stewards of the planet and just do what Mother Nature's been doing for a long time, just harnessing her instead of fighting against her.
And with that being said as well, we always extend and appreciate the opportunity for you guys to leave reviews for us on any of our platforms, whether it's on our website or on our Instagram or on our Facebook or wherever it may be, YouTube. Subscribe to our channels on YouTube, like, comment, share, leave reviews. All these things go farther than you'd think in this digital age that we live in, and we really appreciate it from anybody. So thank you. And to next time, biochar, microbes, and fungi.
Thanks, everybody.
Later.
Good to see you, Kyle.
Good to see you too, Debbie.
Take care.
Absolutely.
Mike, next time we need to work on production value. When we'll have Mike on, we'll just have Mike's pre-recorded times